All right, we're going to do some more temperature testing today. This time we're going to be temperature testing the REF102, the 102. Very nice part. We'll have to take a look at the data sheet, but I think I think it's like 3 ppm or something like that for the temperature drift. We'll be testing it at room temperature and then putting it in a 40°C oven, 40°C oven. And so let's get some paper. We're going to write down some numbers here. We're going to write down the ambient temperature numbers, voltage output and temperature, and then we will record the voltage output at 40°C, and we'll record whatever temperature we get to. So we have currently it's 23.8. And we have 9.99751. All right. Let's, so temperature and voltage up there. And we will put it in the oven. This is my homemade oven. It's right now regulating at 104. It's up to 111 right now. It doesn't matter. We're going to be monitoring the temperature on the board. There's a thermistor on the board right next to the part. And so we will be able to measure the temperature right by the part. So I'll put this in the oven and then we will close it up. All right. And we should watch the temperature start to go up. This is the set temperature. This is the current temperature. Usually when I turn it on, it overshoots a little bit. It takes a while for it to stabilize, but I don't really care in this case because I'm going to be monitoring the local temperature. So let's do a check. We're midway. We're at 28°C. Let's see if our temperature has changed at all. Or our voltage has changed at all. And yes, it's gone up a little bit. It's gone to 99785. We started at 5.1 and now we're at 8. So the last digit is, that would be about 100, 200, 300 microvolts. So we've changed about 300 microvolts. Okay, it's been in the oven about 15 minutes or so. So let's go ahead and write some numbers down, and we'll do some calculations to see how our temperature stability is. We are at 9.99814, and we are at 32.9. That's fluctuating. We'll say 32.9. All right. So let's do some math. All right. So these are our degrees C numbers. So let's look at the delta variation in temperature. We stopped at 32.9. We started at 23.8. That's a 9.1 delta in temperature, okay? And then let's get our delta in volts, 9.99751, 9.99814. We had a 630 microvolt delta, okay? All right. So, how many volts per degree C? So we're going to divide those two. So if I divide this number by 9.1, I get 69 microvolts per degree C. Okay, that's what we're changing. 69 microvolts per degree C. All right. So we need to do a calculation which is, what is that in ppm? Okay, parts per million, because I want to read the data sheet and it's in parts per million. So if we take 10 volts, which is our reference, and we divide that by 1 million, that's our parts per million, okay? So we have 10, and we take a millionth of that. That's going to be 10 microvolts, okay? 10 microvolts. So we actually have 6.9 ppm per degree C. Okay, did you see that math? This is what we have in microvolts per degree C, but every 10 microvolts is a ppm, right? So I divide these two. So we have 6.9 microvolts per degree C. ppm per degree C, right? We have 6.9 of those per degree C. So, and the data sheet has numbers that look really good unless you start staring at them longer and longer. The best part is the C grade. There's a B grade and there's an A grade part, all right? And those have different numbers. So let me write those down. Okay. The C grade part will be 2.5, and this one will be 5, and this one will be 10. All right. Yeah. So the part that we have in the test setup is a REF102B. So we have a B part. So it should be about 5 ppm, and we're measuring 6.9 ppm. All right. So it's certainly within the ballpark. Test methodology is really, really tricky, especially at fine details like this. This particular number is probably case temperature, and I'm not measuring case temperature, I'm measuring ambient temperature. And so to do this right, I probably should have glued the thermocouple on the package itself. And they are separated by some distance, so the part is probably warmer than ambient when it starts out, and then it probably doesn't drift as much. Anyway, that's probably a guess. Anyway, we're measuring about right. We're measuring about 6.9 ppm per degree C, and we have about a 630 microvolt change. So it just goes to show you, if you were building a DVM and you're using this as a reference, and you calibrated it at room temperature, and then you used it on a hot day, be a really hot day, you would see a small change. Not bad. Let's see if we do 10 volts and 630 microvolts. I did that wrong. 630 microvolts. I'm going to confuse you with all these numbers. 630 microvolts divided by 10 volts. Okay. And 100 times. That would be 0.000, I need 3 decimal places, 0.0063%. So 0.0063%. 0.0063%. That's how far you would be off. So yeah, not so bad.